My name's John Lockton from PelicanCorp. We're the damage prevention specialists. We're an Australian company headquartered in Melbourne, but we've also got a presence in New Zealand, Singapore, UK, Ireland, mainland Europe, USA and Canada. Today, I'm going to be going through Geolantis360, our high precision data collection platform. So first of all, I'll introduce Geolantis360, and then I'll go through a few use cases from around the world. So this video that video is showing you what we're aiming to prevent for those in the industry. So typically, a utility plan is an indication of where the underground assets are. There's no guaranteed accuracy. There's generally no depth shown. Disused assets especially may not be shown, that you might come across when you do excavate. And then the new services may not be shown and be up to date on that plan. So Geolantis is a new approach to replacing the as-built sketch. Historically, that sketching process has been very much a manual, paper-driven process where people are hand drawing where the assets are that they've found or that they've been that have been installed. It's time consuming. It's often at the end of the day, so potentially error prone. And then that paper plan is submitted to the office, which then goes through a digitizing process, which is error prone, but it's also time sensitive in that often organizations don't get these paper as-con drawings digitized for many weeks or even months. So Geolantis360 is the high precision data collection platform that PelicanCorp has for aiding in collecting the as-built infrastructure. So it's a digital way of collecting those drawings using an app on your device, whether that's Android or iOS. It's easy to use. It interfaces to high precision sensors. I'll discuss those in more detail in a bit. And it's configurable. So you can set up your feature layers, the feature classes, what colors they're shown in on the map, what attributes you might want to be collecting, any forms that might come up, so you can get sign-offs and so on. And it's easy then to also share that data in deliverable fashion to your clients in a number of ways, and I'll get onto that shortly. So this short session focuses more from the utility locating point of view and getting that information accessible via locators. So what's the focus here? Really, it's how do we map the pipes and cables that locators locate? How do we better do that? How do we enable that? And it's through compatibility with certain sensors and high accuracy sensors. So ones that are a few centimeter type of accuracy, 2 or 3 centimeters, collecting XY position, but also collecting the depth of those assets. Being able to do that offline, so when you don't have mobile coverage, but immediately then when you do, being able to sync your data back to the office so that that data is immediately available, and so that you can then, after finishing the job, go through put that data through the QA process and produce your client deliverables. So as far as sensors go and different devices, Geolantis360 is device agnostic. So from a GNSS point of view, there's a few examples of the types of solutions that we do support. Likewise, on the GPR front, we're device agnostic, and here's a few of the ones we support. And on the EM locator front, again, device agnostic. Delving down a bit more into the EM locator front, the industry trend at the moment is integration of some of these sensors into a combined sensor. So these two examples of basically combining the EM locator along with an RTK grade GNSS device. So the two bulbous additions to these two devices are where the GNSS sensor are located. And what does this provide? I suppose one device, rather than carrying two, they're less bulky, less cumbersome, faster setup, easier startup. So what's PelicanCorp done here? We've done the development to support these two devices, so they're integrated or integratable with Geolantis at a survey grade. But once you've collected the data, then it's how to use it. In this example, it's utilizing it and sending data to a GIS or a CAD system. And there's multiple ways of doing that, either by sharing exports or sharing web services, WFS and WMS services, web services. We've spoken a lot about the application at the user level, the user in the field. The web portal, the Geolantis360 web portal, is the back office environment, and it's here where the project is set up. It's where the data catalogs are set up. So what are the feature classes? What are the attributes, whether they're compulsory or not? If there's any pick lists of attributes so that you can ensure data quality. And also whether there's going to be photographs that you can capture. But also, once you've captured the data, then this web portal is where you do your data quality checks and schedule and do the data export and deliverables to your end user. This environment is also where you manage your users and potentially schedule jobs. So Geolantis has the capability to manage the project, but also schedule jobs to the multiple users that you might have. So just in a workflow fashion, that Geolantis web portal, you can create your project, you can define your work area, your users, set up your data catalog. You can also upload data, so upload existing GIS data so that it can be used to georeference what you're going to capture in the field. So, and then you can also add web services as base map information for that process as well. So you might have aerial imagery that you can add as a base map. The third step is the actual data collection in the field. So you're collecting the let's say the pipelines, the infrastructure. Now they could be points, lines, areas, depending on what you're capturing. It can get that precision data from your different sensors. You can take photographs and annotate them and associate them with a particular point, and you can add digital field notes and potentially other forms as well for getting operational health and safety type checklists, or even sign off from the team lead, or even from the client. And the fourth step is to review the data and create your deliverables. I've mentioned before, yeah, those deliverables can include spatial exports, PDF reports, but also shared web services, so that your clients can get access to actual live data in digital form. I'm going to go through a few use cases. The first one is from the US, from a company called Bloodhound. They're a private locating company. Geolantis360 was introduced to them a couple of years ago. We went through a competitive tender process up against about 14 companies, and we came out successful. And now they're up towards a couple of hundred users. Where the US is a bit different in that their focus is very much painting on the ground. So for each type of utility, different color paint goes on the ground. And that's been the traditional way for locators to operate. What we're doing with Bloodhound is to, at the same time as painting on the ground, to capture the digital information. So capture XYZ information, capture your photographs, capture any field notes at the same time, so that they can then provide that data to their end users as an additional value add. So a couple of examples of what they actually do produce. The first one, yes, they produce a PDF plan with the detail of the underground assets that they've captured. But they also can provide live data to their customers so that they can be more informed, either when they're preparing for the job, but also when they're in the field. So here you can see on the northern side of this road that traverses across the image, you'll see the asset that's being captured. You'll also see the depth of the asset associated with each point. So straight away, their user can be a lot more informed as to what they're going to expect in the field, rather than just having a damn PDF, potentially with no attributes. What they can also do is, because they're accessing live vector data or digital data, is they can drill in. They can click on one of those points, and they can see, first of all, the sensor that captured it. So in this case, it was an RD8100 an EM device. You can see the signal strength, the frequency, the depth. So they can see the integrity. They can see where that data's come from and the quality of that data. They can also click on it and see the XY, so the lat long of that point, the altitude, the depth of where the asset is, what antenna height, the accuracy, but they can also potentially click on associated documents. And in this case, it's a photograph. So all that information being provided to Bloodhound's client, so their end user, so that they can have access to this data in all the time, so that they can be more informed and make better decisions. The second case study that I'm going to go through is from across the ditch in New Zealand, where this is all focused on what can be done with pothole data. Now, the concept of the 5 Ps is well known in the industry: to plan, prepare, pothole, protect, and then proceed. And we're going to focus on that middle one, the pothole. So what is potholing? It's really exploratory test holes so that you can determine where the pipes and cables are, their position in X, Y, and Z, and position including depth. And what's then used for? It's really to confirm where those assets are that are on the plans are in fact there in real life. So you're designing out risk from the project, determining what safe methods there are for working, but also for major projects, you're also determining if utilities have to be relocated prior to the actual works occurring. In New Zealand, about 5% of all before you dig inquiries involve a pothole. So I'm led to believe that's about 10,000 annually. But currently, what happens with that pothole data? It's very much typically it's very much used for the project in question. It's very rarely shared outside those organizations. It's perceived to be not survey grade and hence not always trusted. And it's certainly not supplied back to the utilities. So it's a missed opportunity to upgrade the utilities records, but it's also a missed opportunity that the next time anyone gets a utility plan, that pothole information and that increased quality is not there. So Geolantis for this scenario was used to capture the position of assets whilst they were performing pothole processes. So it was connected to a GNSS device to get that high precision. There were reports filled in. There were photographs taken, and then the deliverable to the client. So here's an example of the Geolantis screen, the project area, along with the assets that were captured. So when you go in, you select the asset type that you're going to capture. It then tells you what additional information you are needed to supply. So the ones with triangles on the right-hand side are the mandatory fields. So you complete the digital form, and then you take a photograph, and that gets associated with that particular point that's being captured. And then that data is exported synced back to the office, and then it can be used digitally in GIS CAD, in this case in Google Earth or even Google Maps. The output in this case study was a PDF of the dig and then we actually also provide the pothole cross section as well, a much more detailed one showing what's happening at the different depths, along with photographs pertinent to that particular pothole. Now, that pothole data is being collected with Geolantis360. It's survey grade quality. It's compatible with most utilities, GIS systems, and that can be shared back to the utilities. They can choose to trust that data implicitly and potentially do a quality check, but then load it into the GIS. Or they might choose to do a bit of a delta analysis of what's majorly different to their current GIS system and what's being provided. And then for the big deltas, they then might choose to visit the location and record the data for themselves. But the big gain here is updating the GIS of the utilities. The utility plans then become more accurate over time. You might even have pothole symbols on the future plans to denote where there have been potholes in the past, which makes the plans inherently more valuable and improves that whole data over time. Lastly, the case study, I want to jump over to Europe. Valvolpen is a contractor to many utility companies in the Netherlands. They focus on a whole lot of horizontal drilling by about 500 staff within the company. They started with Geolantis about 10, 11 years ago and have now got about close to 500 licenses, and they've processed over 35,000 projects through Geolantis. Just going to play a short video of some field training over in New Zealand. Thanks for your time. If you've got any questions, please contact me. Thank you.